Hello and welcome back. Today we are going to talk about an essential topic for mastering technical drawing. Today's lecture is about tolerances. What are tolerances? To answer this question, I would like to invite you to watch this introductory video from our Advanced Geometric Dimensioning and Tolerancing course. Let's start.
What are tolerances, and why do we need them? The story begins with a product that should be developed. This product is developed by following a product development process. We start by clarifying the main function that we want to fulfill. For example, we want a product that achieves a function of an engine, a gearbox, or maybe a pump. Then we break this main function into smaller sub-functions. For example, a piston should be exerting a certain force, and a shaft should be rotating at a certain speed. And the first step to reaching a product that achieves this function happens in the design phase, in which there is a designer or a design department that works on the concept and then creates the drawings for the parts. The drawings specify how the parts should exactly be, which dimensions they have, which material and which quality. So the output of the design process is a drawing. This drawing goes on to the next step, which is the manufacturing process. And in the manufacturing process, a physical part is manufactured to match the drawing. So the output of the manufacturing process is a part. This part goes to the next step, which is the quality control process. The quality control process measures the dimensions of the part and indicates whether the part is according to the drawing or not. So the output of the quality control process is a measurement report and a decision of okay or not okay. If the parts are okay, they will go to the assembly, and the assembly will then be tested for the function. If the function is achieved, then everything went well. But if the function is not achieved, then we have to find out where the error occurred in the whole process. And the answer to the question of why we need tolerances lies in the manufacturing process, because there are deviations and errors in every manufacturing process. Fact is, there is no manufacturing process that can manufacture one part exactly 100% like the next part. There will always be differences between all the parts, and any part will have a deviation from the drawing. So if you specified on the drawing, let's say, some diameter is 30 millimeters, you can be sure that you will never have a manufactured part which is 30 millimeters. Or to be more precise, no part will ever have 30.0000 millimeters. So regardless of how precise the manufacturing process is, there will always be deviations to the nominal dimensions that are specified in the drawing. This becomes even more true when you're designing something that will not only be produced once, but maybe hundreds of thousands of times. These deviations happen because machines vibrate, cutting tools wear, and for hundreds of different reasons. Even when you get into a very precise engineering field, you will still have deviations. They're just not that big, but they are there. And here, tolerances come into play, because by using tolerances, you're creating a way to control these deviations. Tolerancing is stating on the drawing which deviations are acceptable and which are not. You're allowing your dimension or your object to vary in size within certain limits. Tolerances are designed or defined depending on the assembly of the parts and their function. On one hand, the assembly has to be guaranteed. For example, you want to mount a shaft into a hole. You have to make sure that the shaft is always smaller than the hole. On the other hand, the function has to be guaranteed. For example, the shaft should not be too small that it will fit, later on, have too much free play. Maybe this excessive free play will result in acoustic problems, or maybe it will result in some other functional problems in the assembly. So, now we know that we need to use these tolerances to ensure the assembly and satisfaction of the function of the parts.
Now, as we have seen in the introductory video, parts are manufactured according to the dimensions given on the drawing, but manufacturing methods produce parts that meet the required dimension with a certain precision, but never with 100% precision. Even the most advanced and most precise manufacturing methods never produce exact dimensions. There is always a deviation. It's up to the designer to specify the allowable deviation that the manufactured part can have in order to still be accepted. In other words, tolerances are used to indicate the allowable deviation from the nominal dimension. The nominal dimension is the dimension value given on the drawing. Of course, adding more precision using a tight tolerance increases the manufacturing cost, as more precise machinery and more advanced quality control must be used. So, a compromise must be made here to determine acceptable tolerance. As a rule, the tolerance should be as large, meaning less precision, as possible, while still satisfying the function. That's it for this lecture. In today's lecture, we have understood what tolerances are and why do we need them. In the next lecture, we are going to learn about how to put tolerances on the drawing. See you in the next lecture.